All right, so we're gonna solve some systems of linear equations by graphing them, and sometimes graphing them can be easier than other methods of solving. There's a substitution method, there's an elimination method, there's plugging them into a matrix and performing elementary operations, row operations, until it's solved. There's all different ways of solving a system of equations. A lot of times graphing it can be the easiest and most intuitive because you just graph the lines and then you can actually just see where they intersect. So where they intersect, that's where the solution is. Um, whereas with the other methods, it can be hard to really see the answer. So first of all, what's a system of equations? Um, that is my screen is kind of, I don't know. Sorry, should be focusing. Um, Um, it's a group of equation, more than one equation in which the variables have the same meaning. Um, so you deal with them at the same time. So this x, and this x, and this y. So this x and this x and this x would have all the same value. So if it's 7, they're all 7, for example. It's not, but um, this y, and this y all mean the same thing. They would have the same value. Whereas, let's say we have two equations that aren't a system, um, like x plus 2 equals 5, x plus 3 equals 10 million. Obviously, x does not mean the same thing in both these equations. So this is not a system of equations. This bracket is telling me that this is a system of equations. So I want to find their solution. What is the value of x and what is the value of y, um, for which, you know, what is the value of x and y that will satisfy all these equations at the same time. So we're going to do that by visualizing it, by graphing these things and seeing where they intersect. Um, so let's graph these lines first. Um, these are all in the slope-intercept form, which is y equals mx plus b. So this number tells me what the slope is. So on this one, there's kind of an invisible 1 in front of the x. So my slope is 1. And my b, that's telling me what the y-intercept is, where the line crosses the y-axis. So I can use those two pieces of information to graph the lines pretty quickly. So for this first line, the y-intercept is 3, so it crosses the y-axis at 3 with 1, 2, 3. And I'm going to use the slope of 1 to figure out another point on the lines. So the slope is 1. The slope is the change in y over change in x. The symbol, these are bad. Alright, should look like this. No. Like, that's a little better. It's a delta. That just means change. So, how does y change versus how x changes? So, if I have a slope of 1, let me just make that 1 over 1. Same thing, right? So, that means as I move to the right 1, I go up 1, is what that slope of 1 means. So, I'm going to move to the right 1 and up 1. Now I can connect these 2 points with the line. Let me grab my line tool and see if I can. It's pretty close. I'll adjust it. Alright, so what? Yeah, it's pretty close, I guess. Okay, there's that line. I'm gonna actually get rid of these big points just to make more room, and let's make this a little bit thicker. Okay, so that's the first line. Let's graph the second line. So my y-intercept is 2, so it crosses the y-axis at y equals 2. And then the slope is also 2. which I could rewrite as 2 over 1. So that means as I go to the right 1, I go up 2. So over the right 1, up 2. Let's connect those 2 points with a line. Oh, that's pretty good. It goes through pretty well. Let's make that red, I guess. No, let's make it green. And again, I'm gonna move these guys out of the way. All right, so we're doing pretty good here. Let me just adjust it. It's supposed to be. Yes. So these two lines intersect at this point. So that would be the solution if the system included just these 2 lines. So there's a third line in this system. So if it intersects this point, then that is the solution. If it crosses somewhere else, then there would be no solution to that system. As many equations as you have in your system, that many lines have to cross through at the same point for there to be a solution at that point. Okay. So if you have just 2 lines and they intersect like that, then that would be the solution. If you've got 3 lines, they would all 3 need to cross there. If you have 4 lines, all 4 need to cross there, etc. Okay. So last line in the system. Y equals negative 2x plus 6. I know from this equation that the y-intercept is 6. 1, 2, 3, 4, 5, 6. And the slope is negative 2. Also known as negative 2 over 1. That means as I go to the right 1, I go down 2. Negative 2. So go to the right 1 and down 2. Hey, there it is. So something sort of like that. You just adjust it. Yeah, you know, that's pretty close. It's pretty good. Okay, so looks like the solution to this system is at this point. So what is that? So x is 1 and y is 1, 2, 3, 4. 1, 2, 3, 4. Y is 4. So the solution to this system of equations is x equals 1 and y equals 4. That's the value of x and y. If we were to plug in 1 for x in all these equations and 4 for y in all these equations, they would all be true. They would all work out to be correct. So that's the solution. If I were to graph a line and it were to be down here, you know, these 2 lines intersect and these 2 lines intersect, but since not all 3 intersect, there would be no solution for that system. There would be no pair of values of x and y where all 3 of the equations could be true at the same time. You know, so but here, yeah, here there's a solution. So why don't you try to graph these 2? Now these are in point-slope form. So you can change those. You can work with those equations to make them in the slope-intercept form, or if you know the point-slope form. Really, okay, this number is the slope, and then this is the x-coordinate of a point on the line, and that's the y-coordinate of a point on the line, x, y. So you can use that information to plot a point, use the slope to plot another point, connect the lines, and then see where these intersect, and that's the solution to the system of equations.